Well, I noticed that the open dots and solid dots are the same on 3, but different on 1.
Which one of these is obviously weird here? B. So either B is obviously right or obviously wrong. Which one do we think it is?
Wrong.
It's obviously wrong because my y values should be 2, 4, 6, and 8. 2, 4, 6, and 8 should be just constant flat lines. So these slanted lines are obviously wrong. So you can automatically rule out B.
And then out of those 3, the remaining, one of them has the dot on the opposite side.
Okay? And then 2, 4, 6, and 8 should be stair steps going up, right? From left to right. So I should do 2, 4, 6, 8. It looks like D is actually going 8, 6, 4, 2.
I didn't see that.
So D is off. Then I just need to figure out if what is the difference between B, A and C here. It looks like the circles are the difference. One has the closed circle on the left, one has the closed circle on the right. Okay? Now look at where your equal to's are on your equation. Your equal to's are with the number on the left.
They're with the
lower number.
Yeah.
Okay? So my equal to's are with the lower number, then my closed circle should be on the left. Okay? So for the first line is at 2, 0 is closed, 4 is open. Okay, so my closed circle should be on the left because my equal to's are on the left.
So this graph is not showing the function range, it's showing the numbers inside the function range. Right?
Yes.
Okay.
Yes. What you mean just determines how wide it is. Okay? Now, this is a piecewise function, we know that, because that's what we're talking about. So is this a piecewise polynomial function, or something we haven't talked about yet, which is a step function? Well, step function, we haven't talked about it, but that just means it's like stair steps, okay? This is a step function. Now, what is something that we would use a step function for? Like where you have fixed amounts, like 2, 4, 6, or 8.
You could use it for, I guess, energy bill per month.
So the number of kilowatt hours you could choose
I
to be
know.
continuous. Yes.
Like maybe like candy bar sales. If you sell 2 candy bars to 4, you're gonna win this prize. If you sell 4 to 8, you're gonna win this prize.
That could be something like that. Yeah.
You know, like when you're in
follow the
elementary
train,
school.
you get
right.
1. Yeah. What I was thinking of, some of you guys may be too young for this, is when you used to have to put stamps on letters. Like you could only do like 1 stamp, 2 stamps, 3 stamps, 4 stamps. Like you can't do 2.5 stamps. So like if your letter was just a little bit heavy, what? You never put stamps on a letter?
No, we still put stamps on the letters. We're not that young.
Well, I mean, a lot of people.
Well, yeah, but if you go to the post office,
have you seen the thing that's going around Facebook that's called "My Son Doesn't Know How to Address a Letter"?
No.
This guy, have you seen that? Did you see that? Oh my God, it blew me away. This guy was trying to get his kid to write graduation announcements to send to their family. And when he realized that he didn't know how to address a letter, like he didn't know how to, like where to put the return address and where to put the kid had never mailed actual mail before.
You can look those things up online.
What?
You can look those things up
I know,
online.
yeah, but
it just was shocking to him.
Yeah.
That they don't teach that anymore.
Yeah. Yeah. Like you graduated from high school and don't know how to send a letter.
Good job, high school.
Yeah. Alright, so you guys can do some of these on your own.
There's only like 15 or 15.
Are you gonna go with the 9 with a fraction in it? That's just a fraction in your equation. That shouldn't affect the way that you graph it.
We're using the graphing calculator on that one. Do you just use the slash to make the?
Like I would just type that in as 1/6.
Sure.
I did.
1/6x.
See, when I did that, it wasn't for this assignment, but I did that for another assignment I got done.
No, that'll work.
I think you're talking about if you had an exponent next to it.
I think sometimes
If you have more than one thing in there, like if it's 1 over
sometimes you're
x
gonna put
plus
that word
1.
six inside.
It depends if the x is in the fraction or not.
Yeah.
I've
The
had
x
to do
is
that
just
before.
the x is just next to the fraction, just put it next to the
certain
fraction.
amount plus 70 cents per kilowatt hour for customers using
That's always the safe way to use the
up
graphing
to
calculator is to put it
okay. But then they charge more and
Probably
more
'cause it didn't put it in
put in
percentages.
whatever more.
Do you guys want to try one that has 3 equations? Like number 11 maybe?
1100. So let's see, it would be
3 equations? Okay, let's look at a number 11. Number 11 has a fraction and 3 equations. So we get everything all at once. Okay, number 11, I've got negative 1/4 x minus 2. So I would just type that in as negative 1/4 x beside it minus 2. Negative 3 is my second equation, and then x is my third equation. So you can just put negative 3, you can just graph that. It'll just be a straight line, and then x. Okay? Now I'm going to have 2 splits here. So where were my splits? I don't remember. Walk away from something for 1 second, I can't remember. Okay, so x is less than or equal to 4, between 4 and 5, and then greater than or equal to 5. Let's see if I can remember that.
That's problem 11, you say? Mine doesn't have a fraction.
Well, if you do have a fraction, just type it in like that. There's other ones that have fractions. They all work the same way. Okay. So my splits are happening at positive 4.
Geez, that looks complicated.
And then right next to that at positive 5. Okay.
So green is only, you only look at green inside that small section.
Right. Did you guys hear what he said?
No.
The green line is the negative 3, the horizontal line. I only want the green line between 4 and 5. So the green line is only going to exist in this little section.
That eliminates a couple of them right.
Okay? The horizontal line should be only in that little section. It's only between x is 4 and x is 5. So only this little part of the green line for negative 3.
Blue is above 5. Greater than or equal to 5, so to the right.
Let me
Yeah, sorry.
right here. Now what should I start and end the green line with? Open circles, closed circles?
Open.
They're both open because neither of those have equals here. I want an open circle here, open circle here, and no other green line. Okay? Now, I just have to sort out red and blue. Okay? I'm going to have one on the left, one on the right. So, where should the red line be? To the left of 4 or to the right of 5? Red line should be to the left of 4. Okay, so red line should be over here. The blue line should be to the right of 5, which is over here.
Yeah, I know, right?
So red line should be on the left. Okay, now it looks like the red line and the green line are actually intersecting right there, which would make that no circle or a closed circle.
It would.
If you've got a closed circle overlapping with an open circle, then it's kind of like the closed circle covers up the open circle.
Oh, okay.
Wait, what? What are you saying?
See how my red line and my green line intersected right here?
Yeah.
The red line would normally end with a closed circle. Since they're at the same point, that closed circle would just kind of cover up the open circle that I already had. And yours may not intersect. Did yours intersect?
No.
No, not quite. So you'd have two different circles.
Okay, but now if they did, this would be a closed circle.
Yeah, if they overlapped. So what I've actually got going on here, besides all of the squiggles, is I've got this, and then this. And that would be what I would be looking for on my graph. Oh, I messed up here. What did I mess up? It's -4, not +4. So I completely kind of mucked this up here. So this is still going to look the same. My green line is just going to be a lot longer. It's going to go from -4 to +5, not +4 to +5. My red line would still be on the left. My blue line would still be on the right. Did you guys get number 11? Yeah? Come on. Kind of mucking around there. Sweet. Okay. Last thing we want to look at are some of the word problems. We got to think about these. Okay, so here's a kilowatt hour problem. Okay? So let's think about this. Read through number 12 and think about it for a second. So for the non-extreme weather month, the company charges $8.10 plus 5.747 cents per kilowatt hour, up to 1,200 kilowatt hours, and charges 77.064 plus 3.788 cents per kilowatt hour above 1,200. Okay, now up to 1,200. What does that mean in terms of inequality?
It includes it.
Okay, I messed up. Okay, up to 1,200 would be like less than, greater than, less than or equal to, greater than or equal to, up to something.
So X is less than or equal to 1,200.
Up to 1,200 would be less than or equal to 1,200. Okay? So up to 1,200, I'm going to be charged $8.10 plus 5.74 cents per kilowatt hour. Okay? my first category should be X is less than or equal to 1200. Up to 1200. So which one can I rule out here right away? If my first category should be less than or equal to 1200. I can rule out B. B has greater than or equal to 1200. Okay, so this is wrong here. I can rule out B. Now what is the difference between A and D?
That they don't have on the 0.074.
Okay. So A has your decimal point moved over for the cents. B just has dollars and cents written the same way. Is D correct? No, because this is dollars. Cents should have the decimal point moved over. So D is out because of those cents. So they don't mean $5.747 here. So that's wrong. That's wrong. D is out. So what's the difference between A and C? Subtracting the first 1200 in the second equation. Do we like that or not? Why would you subtract the first 1200? You've already paid for the first 1200. You paid for the first 1200 in this $77. Okay? Guys, take a second and take this first equation and plug in 1200 into this. This 810 plus 0.05747x. Plug in 1200 there into your calculators. You guys have calculators. Do it now. 810. I'm going to do it too. 810 plus 0.05747 times 1200. What do we get? You should get 77.064. 77.064. You're already paying for the first 1200 in this number. So to pay for only the extra, you got to subtract it. Okay? So this subtracting it basically means you're only paying for the extra here. You already paid for the first 1200 in this number. Okay? That's where that number comes from. Okay? So A, you would be paying for the first 1200 twice. C is correct. Okay? When you're doing these sort of tiered pricing schemes, you're always going to have to subtract the amount from the previous tier because you've already paid for that much. The second tier, you're only paying for the extra at the higher rate. Now that'll come in handy on the one where you have to write your own equation. Let's finish this one first. Okay, so minus D. Okay? What is the monthly charge of 930 kilowatt hours were used? What would I do there? Plug in 930. 930 is less than 1200, so you'd fall in the first category. Just plug it in. Okay, so I'm going to plug in 930 into my first equation. 810 plus 0.05747 times 930, and I get 61, rounded to two places, 61.55. Okay, you gotta round that to two places because it is money. And then for the second part, what is the monthly charge of 1210 for you? Okay, so remember the first 1200 you already paid for in the 77.064. You're only paying for 10 extra. So I'm actually going to go ahead and just subtract that in my head and just multiply that second number by 10. Because I'm over by 10. I get 77.064 plus 0.03788 times 10.
So in this equation, if we hit say like 1500, will we just simply take 1500 minus 1200 and do the equation?
Yep, you pay for 300 extra.
Okay.
You went over by 300.
Worked it all out after I did the problem.
Apparently I used a lot of power last one. My power bill was $200. So
how many kilowatts?
I don't know, but it was crazy high. Like I don't know if
Because it was really hot.
It was really hot in the air. My air runs like constantly.
It sounds like you need a
Kind of shocking. Like I opened it, I was like, oh my god. Need to get my house weatherized. Actually, I need new windows.
Wait till August.
yeah, right.
Okay, 13, 13, you're basically just copying the numbers from over here, so you guys can do 13.
Excuse me.
Let's look at 14. 14 is the postage question. Okay? Remember we talked about postage is something where you can only pay fixed amounts. Okay? So which equation only has fixed amounts? You've got to think about it. So you can only pay like 1 stamp, 2 stamps, 3 stamps. You can't go in between stamps. I would have to choose B. Postage only comes in fixed amounts. So for the first one, I would pay 43 cents for my first ounce. My second ounce, even if I only go over by like 0.01, I would have to add the 24 cents. 24 cents would put me up to 67 cents. Okay, then you add 24 cents again for the third ounce, or the second ounce, sorry. Then you add 24 cents again for the last ounce. Okay? After that, they make you do Friday mail, right? Okay. Then they want me to find P of 1.1. Okay? 1.1 would mean I have 1 ounce and then 0.1 ounces. So I'm over 1 ounce by 0.1. So which category would I fall into? The 67, right? So the fraction of the ounce puts me up into the second category. Okay? This means that the postage on a 1.1 ounce letter is 67 cents. Give the domain of P. You guys remember what domain is? X values. What X values am I covering in my function? 0 to 4. Okay? Because my function lets me do anything from 0 up to 4 ounces. After 4 ounces, I've run out of equations, right? So my domain should be 0 to 4. Okay? Now you want to make a note that the 0 does not have an equal to. Because what would a letter that weighs 0 ounces be?
Free.
That doesn't exist, right? So you can't actually include 0. So I want 0 less than x, less than or equal to 4. 4 is included.
You mean we can't send imaginary letters? Math just can't be real.
And it's called email. That's a letter weighing 0 ounces.
No, it's about 4 pounds if you count the weight of the laptop.
Well, that's true. Okay, some of these go on and on forever.
And this would be 1.
Okay, P of 2. With 2 would fall in one category, and then 2.01 would bump you up to the next one. So for 2 ounces, I could still get in 67 cents. 2.01, I'd have to go up to 91. Okay? I think what they're trying to show you here is if you go over even the slightest amount, you have to put a whole nother stamp on it. Even if it's over just a little bit.
Thank goodness amount is forgiven.
And, yeah.
Thank goodness we really don't have to ever mail anything ever.
That's a false statement.
That's not for me. I don't mail anything.
I don't really either, unless it's like a thank you card or something.
What?
No.
For the pieces?
No, for the pieces. It asks the same question.
Yeah, it asks the same question over and over again.
Trying to trick you.
Okay, there's one more I want to look at, and it's the tax question. Let's see if we can find that.
Would be the next one.
The next one, the tax question. Taxes are another place you guys may have used piecewise functions and not realized it. Because for taxes, you look up, the way it actually works is they say, like, the first so much of your income is taxed at one rate, and then the next however much is taxed at another rate. You know, if you actually calculate your taxes instead of having somebody do it for you. You have to look it up in a table. Okay, so this tells me that if my income is between the number on the left and the number on the right, then my tax is the fixed amount plus a percentage of the income over this much. Okay? Now, one thing that's confusing about this question is that they're only asking you to write a function for two categories. So my first category is 0 to 34,870, and then my second category is 34,870 to 110. So what you want to do is you want to kind of just look at those two rows of your table and ignore everything else. So 0 to 34,000 would be the first row.
Which is 16%.
34 to 110 would be the second row. So I'm actually going to ignore these last rows of my table because that's the more stuff you have to look at, the more confusing it gets. So I'm just going to ignore these so we don't even have to look at them. Okay, so what would my first equation be? 0.13x? Okay, how do we get that?
It's 13%.
It would just be 13% of your income. So if your income is below that much, you just pay 13% of your income. So 0.13x is how I would calculate that.
I might add that we know this is going to equal. Why is this by this function? So wait, why are we writing 0.3x?
The first category, if your income is between 0 and 34,000, you just pay. You don't pay any fixed amounts. See, they've got those dashed lines there. You
Okay,
don't
so
pay a fixed amount. You only pay 13%.
So we're not actually not answering the problem. We're putting in a function.
Putting in a function, yeah.
Oh.
Not actually figuring out what the tax is yet. We're just
input.
figuring out how you would calculate it.
Input x at models
Okay.
tax dollars. Okay, I get it.
Now my second equation, I would pay a fixed amount plus 23% of the amount over the first amount.
How did you say you can restart the whole thing without?
Help me solve this.
Help me solve this. Okay, so for my second category, I would pay a fixed amount of 4533.10 plus 23% of the amount over. Remember, to get the amount over, you subtract. You do x minus 34,870. Okay, so I pay this amount plus 23% of the amount over this. You get the amount over by subtracting it.
Isn't there an X on the backside of oh no, you got that right, never mind.